Yeah, this week we will discuss about the problems in AC circuits. AC circuit is a circuit which consists of voltage source or current source which is sinusoidal in nature. A sinusoid is a signal that has the form of sine or cosine function. The first problem let us take here is given as for the circuit given in this figure, which has three inductors, one with 2 Henry and other 4 Henry and 12 Henry uh, connected to each other in series and parallel combination. They are asking you to find certain things like I1 of 0, V of t, V1 of t, V2 of t, I1 of t and I2 of t. The given data is I of t. And also they have given I2 of 0 is minus 1 milliamps. Given data are two things and they have asked you to find 5 different voltages and currents from the given circuit. First thing, let us write what to find and uh, what is given. The given data is I of t and I2 of 0, but they have asked you to find I1 of 0, V of t, V1 of t, V2 of t, I1 of t and I2 of t. Before getting into this, we will try to understand this problem first. For understanding this problem, we need to understand certain things like in AC circuits, the current varies with time, so it is denoted as I of t and I1 of t, not as I small I or capital I in DC circuits. Here it is I of t and I1 of t likewise. So voltage also varies with time, so it is given as V1 of t, V2 of t, etc. And here we have inductors connected. Both inductor and capacitor is a storage element. So it may have some stored energy before it is connected to this circuit. That value of current stored before it is connected here is named as I of 0, and it may vary as I of 0, I1 of 0 and I2 of 0 according to the currents we are assuming. Likewise, voltage will also vary as V1 of 0, V2 of 0, etc. And we need to know certain other things like what is the formula for series and parallel connections of inductors and capacitors. Here we have inductors, so for finding the equivalent value of the inductors and capacitors we need to know the formulas. For parallel connection it will be, for parallel connection of inductors we need to take reciprocal and add it, and for series connection it is just addition of all the inductors which is connected in series. Apart from this inductance, we need to know the voltage current relationship of an inductor, which is nothing but V of t equal to L into di by dt. This also should be known because for solving each and every problem in an inductor, this is the one which is basics. And at last we need to know integration and differentiation basics. Only with that we can solve the problem. Before starting this solution, let me give a brief introduction on AC circuits which is taken before. AC circuits will have the things like this. See, the sinusoidal voltage will be of the form V of t equal to Vm sin omega t. Because it is of sinusoidal in nature, you can see here, it will not be like a DC which will be a straight line. And Vm is nothing but the amplitude of the sine, this height. And omega is nothing but the frequency in radiation. So omega t is the argument of the sinusoidal function. From this only we can understand why we are making this as V of t or I of t, because it is varying with time. Okay, with this small knowledge, see the voltage current relationship. When a current is passed through the inductor, the voltage across the inductor will be calculated using this formula V equal to L dA by dt. Inductance is a property whereby an inductor exhibits opposition to change in current flowing through it measured in henries. These are the basics. And the connections through for inductance in parallel and series is given here. Series inductance, we have to add the total inductance. For parallel inductance, we have to take the reciprocal of sum of reciprocals of the individual inductance. This is the formula for finding the equivalent inductance. when they are connected in parallel. And there are certain basic elements or the formulas when a resistor, capacitor, and inductor is connected in a circuit. The IV characteristics, VA characteristics, power formula, series connection formula, and parallel connection formula is also given here. These will be useful. Only with these formulas we can solve the problem. Now we can directly get into the problem first. The problem solution will be like this. See, first we'll start with finding I1 of 0. What is I1 of 0? It is nothing but the current which is stored in the inductor before the inductor is connected to this circuit. See, I1 is nothing but the current flowing through 4 Henry. And what is I of t? I of t is given as 4 into 2 minus e power minus 2 minus 10t. This is given here, milliamps. And so substituting t equal to 0 in this, we'll get I of 0. So here we don't have t, only in e power minus 10t we have t. So substitute t equal to 0, this becomes e power 0 which is equal to 1. So 4 into 2 minus 1 which is equal to 4 milliamps. This is here I of t or I of 0. And this current I is going to divide into I1 and I2. That is given here. I is equal to I1 plus I2. So from that we can write I1 of 0 will be equal to I of 0 minus I2 of 0. Okay. See, I1 is taken to the left and I2 is taken to the right. So I1 of 0 equal to I of 0 minus I2 of 0, which is equal to I of 0 we have found here, it is 4, and I2 of 0 is already given. So substitute and find I1 of 0. This is the first thing they've asked, we found it out. The second one is equivalent inductance. Why we are finding equivalent inductance? Because they have asked you to find V of t. V of t is nothing but L into di by dt. Here V is the input or the source voltage. For the source voltage, we have 3 inductance connected, so we have to find the equivalent inductance. So equivalent inductance is nothing but the series and parallel connection formulas. Here we have 2 inductance connected in parallel, and these 2 parallel combination is in series with 2 Henry. So first parallel this 4 and 12 Henry, which will be 3, and add it to 2. So you'll get 2 plus 3 equal to 5 Henry. Substitute this 5 Henry here. And what is this di by dt? Di by dt is, you have been given with it, substitute that I here and differentiate with respect to t. You'll get the answer. I'll show the differentiation which I have done before. See, I have substituted that 4 into 2 minus e power minus 10t, and I am going to differentiate. What will happen? This y is constant and 4 is also constant. Take it out. And what happens to this 2? Differentiating this constant with respect to t, it will become 0. Leave it out. Differentiating this e power minus 10t with respect to t, you will get minus e power minus 10t into minus 10. Already minus is there. So minus 1 into minus 10 will be plus 10. Plus 10 into 4 into 5 will be 200. So 200 e power minus 10t millivolt will be the answer. Why millivolt? Because everything is given in milliamps. So at last we will get millivolts only. This one is V of t. Now we have got V of t, and you have been asked to find V1 and V2 also. For V1, what should you do? Just substitute the I1 in the place of I. So substituting I1, we already found I1 of t. So substitute it here, you will get V1, the same procedure. How can you find Vt? V2 of t is nothing but, let us go there. What is V2? V2 is the voltage across 4 Henry and also 12 Henry. So we cannot decide which one is. Both the voltages are same. So we can take this 4 Henry and solve, or we have other thing which can be used. See, V2 equal to V minus V1. This V is going to divide into V1 and V2. So V2 can be written as V minus V1. So they are using this. V is 200 e power minus 10t V1 is 80 e power minus 20. So subtracting you will get to 120 e power minus 20 millivolt. At last we've been asked to find I1 of t and I2 of t. I from what is first of all find what is I1. I1 is the current flowing through core entry. For finding this, we have the formula for I, which is nothing but I is equal to, you can see it here in the presentation I've shown it before. See, I is when inductor is connected, I is equal to 1 by L T naught to T V dt plus I T naught. It is I0 here. So we can go there. Substitute what is 1 by L. L is here 4 Henry. So 1 by 4, 0 to T. Why 0 to T? Because we have divided it into before value and the now connecting value. So 0 to T, V2 of T, V2 of dt, then I1 0. Here what happens? Substitute V2 which is here. So 120 e power minus 20 is substituted here. 120 is constant, so take it out. 120 by 4. E power minus 20 when you integrate plus I1 of 0 as we have found it as 5 milliamps. Substitute it from here. So I1 of t will be this one. When you integrate this one, you will get 120 by 4 is 3. E power minus t when integrated, you will get e power minus 10t divided by 10, minus 10. So it will become minus 3 into e power minus 10t. We have to apply the limits t and 0. When you apply t, it becomes this the same. When you apply 0, this becomes e power 0 which is equal to 1, so minus 3. Minus of minus will become plus. So this is upper limit value, this is lower limit value, and the 5 which is already there, so it becomes 8 minus 3 power minus 10t milliamps. Similarly, for I2 of t, what should you do? You should substitute the same. Here we have substituted now same value. Only thing is I2 of 0 will vary. Here I1 of 0 is 5 milliamps. Here I2 of 0 is 1 milliamps. Substitute, and you will get somewhat around the here 1 by L is what is this? I2 of t. So I2 is flowing here. So 12 Henry should be substituted. 12 Henry is substituted, and afterwards 120 by 12 will become 10, and e power minus 10t when you integrate it will become e power minus 10t divided by 10. So this 10 and this 10 will be cancelled. So it becomes minus e power minus 10t minus this 1 milliamps. E power minus 10t is this is the upper limit value, this is lower limit value, and this is the third value. So final answer will be like this. This is your first problem. Just try to recall and try to solve this problem. Here, what is the difference between the previous problem and this problem? The same thing is asked here, but the thing is here, there we have parallel combination in series with this. Here, the parallel combination is given first and then the series combination is given at the last. Other things are same. Try to solve this problem and get the answer. We can verify the answers given below. The answers you have solved. Thank you.